The basic data type in PyTorch is torch tensor, and it's technically a Python class. You can use it to store scalars, vectors, matrices, or higher order tensors. What makes a torch tensor special is that it can be used as an optimization variable, and it can store a gradient, basically, a gradient of some loss with respect to itself. So that's what makes it interesting and, for example, different from a NumPy array. So the basic way of creating these, or the preferred way of creating these tensors is using this torch tensor function and passing it a list and some parameters. Here we pass this parameter requires grad. We pass true to requires grad, which informs PyTorch to keep track of the gradient of this, of some loss with respect to this, as we'll see. So if I run this, you can see that it creates a tensor with the numbers, and also the tensor has a property requires grad, which is true. We can check the shape of this. This is basically a vector, so the size has just one, if you want, 0th dimension, or I can check the size using the size function. Okay, and then I can create a loss from this vector by some manipulation. So here we have a linear combination and some nonlinear operations. So if I run this, you can see this is a new tensor derived from W, and it's a scalar tensor. So we can represent scalars using PyTorch tensors as well. So this models this loss function that we have, as you can see. And the next step is now to compute the gradient of this loss with respect to W. Okay, so let's try to compute the gradient of the loss with respect to W. So every torch tensor, like W, has a grad property. And you can see this attribute is none by default and becomes a tensor the first time a call to backward computes gradients for self. So if the first call to backward somewhere computes the gradient for W, this is going to be updated. So the call to backward in our case would be on loss. So we call backward on loss. And so every PyTorch tensor has a backward function as well, and you can read that this computes the gradient of the current tensor, which is loss, with respect to graph leaves. In this case, these are just W, it's just one, it's W. And so it computes the gradient and basically adds it to whatever is in W.grad if there is something there. Okay, so if I run this, you would see that first it's none, and then the W.grad property is populated by the gradient of the loss with respect to W. You can verify that if you plug in the current value of W into this gradient formula, you would get this. So we properly calculated the gradient. So something to note is that loss.backward does not do anything to loss, but it performs a so-called side effect. So it modifies something outside loss, which you might not expect. So how does loss know about W? It knows about it because it was used in creating loss, and we also required the gradient with respect to W. So when you create loss, somehow a reference to W is stored in loss, and so when you call backward on loss, this performs the differentiation and stores the gradient in W.grad. So this is good to remember to avoid confusion.